Hello listeners and viewers. Welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration, under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned, as always, to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Hi learners, you are welcome to another session of our e-learning program organized by the Kaduna State Ministry of Education. And on the subject physics, we are rounding up our discussion on measurement of heat energy. And the part we are looking at today is part 7, a continuation of vapor pressure, which we treated last lesson. So far, we've been able to see that measurement of heat energy are segmented into 7 parts. The first part talk about specific heat. Second part, continuation of specific heat. The third part was change of state. And then we went on to see latent heat as part 4. And part 5 was a continuation of latent heat. Latent heat, part 5, and then part 4 and part 5, latent heat continuation. And last lesson, as I said, part 6 was first part of vapor pressure. And today we are rounding up our measurement of heat energy and vapor pressure continuation. So far, the outline on the vapor pressure continuation, the first part there is formulae. That is, we've been able to define some terms, which was what we saw last lesson. Definition of some terms. What is hygrometry? What is vapor? What is vapor pressure? What is saturated vapor? And then unsaturated vapor and saturated vapor pressure or saturation vapor pressure. We're able to also see the properties of saturation vapor pressure, the difference between saturated vapor pressure and unsaturated vapor pressure, as well as the difference between gas and vapor. And so the second part of our outline is examples, and then we look at the assignment. On the formula, we have relative humidity, and as defined, it is a ratio of the mass of water vapor present in a certain volume of air to the mass of water vapor required to saturate the same volume of air at the same temperature. I take it again. Relative humidity, very important, is a ratio of the mass of water vapor present in a certain volume of air to the mass of water vapor required or needed to saturate the same volume of air at the same temperature. And alternative definition of relative humidity is given and we have it as this. In formula form, we can put the relative humidity as equals to mass of water vapor in a given volume of air. And we are using small letter m to represent the mass of water vapor in that given volume of air. Then over the mass of water vapor required to saturate the same volume of air at the same temperature, and we are using capital M. Then the expression is, the fraction is multiplied by 100%. The second alternative of our relative humidity definition is given in formula as relative humidity equals to saturation vapor pressure at dew point over saturation vapor pressure at the original air or at room temperature. Whether I say original air, original temperature, the same thing, or room temperature. And then we also multiply the formula by 100%. The third definition or relative humidity given in mathematical form is relative humidity is equal to vapor pressure, and we use partial pressure to also represent that vapor pressure in this case. And so we say relative humidity is equal to vapor pressure in bracket partial pressure of the air over saturation vapor pressure at the temperature of that air, of the air. And again, we multiply our formula by 100%. Now, we have this in summary as relative humidity is equal to small m, which is mass of water vapor present in air, over capital M, which is mass of water vapor needed or required to saturate the same volume of air at the same temperature, then multiply by 100%. So if you're asked to solve problem, all you need to do is to code this formula, substitute your values, and compute. And also, the second alternative definition of relative humidity is also given as thus in mathematical form in summary, as relative humidity is equal to SVP. And SVP refers to saturation vapor pressure at dew point over saturation vapor pressure, that's SVP, at original air, in bracket room, and then temperature. I take it again, relative humidity is equal to SVP at dew point over SVP at original air or room temperature multiplied by 100%. And so we have also the summary of the third alternative of our relative humidity in mathematical form is given as relative humidity is equal to VP, which is vapor pressure, over SVP multiplied by 100%. And all we have seen is relative humidity is always expressed as a percentage. You know the formula, you can see multiply by 100%. So relative humidity is expressed as a percentage. The values of relative humidity are used by weathermen or meteorologists. An aspect of physics known as meteorology, that is weather forecast. Weather forecasters use it for making weather forecasts. And when at the end of it, maybe newscasting in our daily television, news, whatever, we always have the weather of a given city or major cities being given. Maybe the low temperature, high temperature. Which one will have rain, which one will not, and so on and so forth. This information is obtained using this formula, relative humidity, to be able to predict what temperature a given city is going to have, low or high. And then we also have rain, possibility of rain happening or whatever weather may be in a given city. And then the instrument we use for measurement of relative humidity is known as hygrometer. Hygrometer is an instrument we use to measure relative humidity. Example of such is the wet and dry bulb hygrometer. Now, as I said in our outline, the first thing there was formulae, and that is what we have been able to see. Next will be examples, and we look at just 3 examples under this part 7, the last segment of our measurement of heat energy. Example 1, the mass of water vapor in a certain volume of air is 0.20 gram at 30 degrees Celsius or centigrade. What is the relative humidity of the air if the mass of water vapor needed to saturate it, that is that same volume of air at the same temperature, is 0.35 gram. Solution. Our mass of water vapor at the given volume of air is small m, as we have in the formula, equal to 0.20 gram, and our m capital is 0.35 gram. That's water vapor needed or required to saturate the same volume of air at the same temperature. And as we say, the formula has been treated. Relative humidity is equal to small m over capital M multiplied by 100%. The substitution is made to give us relative humidity is equal to 0.20 over 0.35 multiplied by 100%. And if you multiply through and make our necessary computation, our final answer will be relative humidity is equal to 57.14% to the nearest 2 decimal places or 4 significant figure. Example 2. On a certain day, the dew point is 10 degrees Celsius. When the temperature of the air is 32 degrees Celsius, calculate the relative humidity of the air. Given that SVP, saturation vapor pressure of water at 32 degrees Celsius and 10 degrees Celsius are 16.2 millimeter and 9.8 millimeter of mercury respectively. Our solution is as thus. SVP at dew point 10 degrees Celsius is equal to 9.8 millimeter mercury. Our SVP, saturation vapor pressure at air temperature 32 degrees Celsius, is equal to 16.2 millimeter mercury. Again, our formula has been given as relative humidity is equal to SVP, saturation vapor pressure at dew point, over SVP at air temperature multiplied by 100%. We make our substitution for dew point SVP to be 9.8 as given in our sorting out of data, to be divided by 16.2, our SVP at air temperature, and multiplied by 100%. Again, using our knowledge of computation, we just multiply through by 100% the numerator and then divide by our denominator 16.2 to give us relative humidity 60.5% to the nearest 1 decimal place. And that gives us the solution to our second example. Our example 3. The table below shows the saturation vapor pressure against temperature in a particular city. If on a certain day, the vapor pressure in this city at 30 degrees Celsius is 22.0 millimeter mercury, what is the relative humidity? The table is given in 2 rows and many columns. Our first row is capital T to power naught C, that is temperature in degrees Celsius against saturation vapor pressure in millimeter mercury. The first column after the column of those parameters is 0, and the corresponding SVP, that's when the temperature is 0 degrees Celsius, the SVP in millimeter mercury is 4.6. When it is 10, we have 9.2. When the temperature is 20, our SVP is 17.5, and 30 correspond to 31.8, 40 goes with 55.1, 50 goes with 92.5, and 60 goes with 149.0. Please take note that the table has to the nearest decimal 1 place, and it's very important. The solution to our final example, question 3, example 3, is VP, vapor pressure of air at 30 degrees Celsius, is given by 22.0 millimeter mercury. and SVP, saturation vapor pressure of air at the same temperature, 30 degrees Celsius, is equal to 31.8 millimeter mercury. The second one was gotten from the table. The corresponding value of our SVP for temperature of 30 degrees Celsius, which is the same temperature as the VP of air, is 31.8 millimeter mercury. Again, our solution has this formula as relative humidity is equal to VP, vapor pressure, over SVP, saturation vapor pressure, multiplied by 100%. And so our VP is given as 22.0 millimeter mercury substitute 22.0 over 31.8, which is the saturation vapor pressure, and multiplied by 100%. Our simple computation arithmetic will give us relative humidity formula is 69.2%, and that is to the nearest one decimal place. Right? With what we have done so far, I believe you have an understanding. But all the same, let's have a review of what you have just treated this morning. We started a last segment of our measurement of heat energy, that is part 5, under vapor pressure continuation. Relative humidity defined as the ratio. And when we talk of ratio, it simply means divide by, over, of the mass of water vapor present in a certain volume of air. Of course, we don't know what volume of air such mass of water is being contained. All the same, we have a certain volume of water and a certain volume of air that the mass of water is inside. And then we divide it by the mass of water vapor needed to saturate the same volume of air at the same temperature. There are two things there. Volume of air must be the same, and its temperature also must be the same for the water needed to saturate. What we mean by to saturate is to fill it up. You know, if for instance you have 30 millimeter cube or 30 cubic centimeter, and then you have water of mass less than that 30, that will be the mass of water present in that volume of air. But what will not be needed, the water needed to fill it up must be that 30 millimeter cube or cubic centimeter. That is what it means. That is to fill up that volume of air, and that is meant by saturation. Saturated means to fill it to the brim, and the temperature of the mass of the air in that volume, not filling it up, must be the same as the one that will be needed to fill it up. That's just what it means. Volume and temperature of both must be the same. That's relative humidity. And we say that in mathematical statement, we have relative humidity is equal to mass of water vapor in a given volume of air, and we use small letter m to represent mass of water vapor in that given volume of air, divided by mass of water vapor needed, required to saturate the same volume of air at the same temperature. Capital M is used to distinguish between the two, and we multiply by 100%. And where we are now saying we have alternative definition of relative humidity. It can also be defined as saturation vapor pressure, SVP, at dew point. We have defined dew point in our last lesson on definition of terms. The temperature at which water present in air is just sufficient to saturate it. That's what dew point is all about. So saturation vapor pressure at dew point over saturation vapor pressure at the original air or room temperature, then multiply by 100%. Then the third alternative definition of our relative humidity is in terms of vapor pressure and saturation vapor pressure, which is given a relative humidity is equal to vapor pressure, and we replace it by partial pressure. Whether it's a partial pressure or vapor pressure is the same. Relative humidity is equal to vapor pressure or partial pressure of the air divided by saturation vapor pressure at the temperature of that air, and then multiply by 100%. Again, we have the summary of our mathematical statement of these three definitions as follows. Relative humidity is thus given as small m over capital M multiplied by 100%, and relative humidity is equal to SVP, saturation vapor pressure, at dew point over saturation vapor pressure, SVP, at original air temperature or original room temperature, and multiplied by 100%. And then alternative last definition is relative humidity is equal to vapor pressure VP over SVP, saturation vapor pressure, multiplied by 100%. And we said relative humidity is always expressed in terms of percentage. Anytime you are obtaining your value, please, if in a marking scheme, we discover that if you omit the unit or wrong unit is being attributed to a given physical quantity, you miss a mark. So percentage must be expressed. Anytime you calculate relative humidity, that percentage must be attached to it. Otherwise, they deduct mark for it. And that's why we say, as emphasis, relative humidity is expressed as a percentage. And as I said, the values of such are used by experts in physics known as meteorologists or weather forecasters to be able to know or predict the weather in a given city. As I said, we always have prediction of either high or low temperature of certain major cities in our country and the world entirely once the end of the news is being given. And we said we have an instrument used for that measurement of relative humidity. We refer to it as hygrometer. And we say example of such hygrometer is a wet and dry bulb hygrometer. And we said examples have been given. The first example is one that has to do with mass, small m over capital M. The mass of water vapor, for instance, in a certain volume of air is 0.20 gram at 30 degrees Celsius. What is the relative humidity of the air if the mass of water needed or require vapor to saturate that same volume of air at the same temperature, that is 30 degrees Celsius, and the mass given needed to saturate is 0.35 gram. Don't forget, the small m is always less than capital M, or capital M is greater than small m to be able to give you what you want. And then the solution, we say our small m is sorting out data will be 0.20 gram, our capital M will be 0.35 gram, and the relative humidity is given as m over small m over capital M multiplied by 100%, which is equal to 0.20 over 0.35 multiplied by 100%, and the relative humidity by the expression will be 57.14%. And then the second example and the third one also has been given so far. With this, I want to hand over to my colleague in the person of Buki Hassan. Once again, I remain Napoleon Kure. Keep reading. Stay at home. COVID-19 is real, and remain safe. Thank you.
Good day, learners at home. My name is Hassan Buki. I believe you have followed what my colleague Mr. Napoleon Kure has delivered to you on this last part of measurement of heat energy, part 7. Now, today we have concluded on that topic, measurement of heat energy. And I will advise that you go back again to your textbooks, read carefully, attempt questions in your textbooks, in the exercises in your textbooks, and also pick WIEC and JAM past question papers and attempt them. Doing that will make you to really fully understand the topic. Now, before we conclude finally, I will leave you with an assignment to keep you busy so that you attempt them, you try yourself and see whether you have followed what has been delivered onto you. So, assignment. Question number 1. The mass of water vapor in a given volume of air is 0.05 grams at 20 degrees centigrade, while the mass of water vapor required to saturate it is 0.15 grams. Calculate the relative humidity of the air. 2. If the partial pressure of water vapor at 27 degrees centigrade is 18 millimeters mercury, and the saturated vapor pressure of the atmosphere at the same temperature is 24 millimeters mercury. Find the relative humidity at this temperature. 3. The table below shows the saturation vapor pressure against temperature in a certain town. If the vapor pressure in this town at 20 degrees centigrade is 10 millimeters mercury, what is the relative humidity? Now the table, the first row we have temperature in degrees centigrade, and the second row we have SVP, which is saturation vapor pressure in millimeters mercury. Now, first column we have temperature as 0, and the corresponding SVP is 4.58. The second column we have temperature as 5, SVP as 6.51. Third column we have temperature as 10 and SVP as 8.94. Next column we have temperature as 15, then SVP as 12.67. The next column we have temperature as 20 and SVP as 17.50. Next column, temperature is 40 and SVP 55.10. And the last column we have temperature as 60 and SVP as 149. That's 149.00. References: 1. New School Physics by M.W. and Yakoha. 2. All-Inclusive Calculations in Physics by Solomon Dauda Yako. 3. Senior Secondary School Physics by P.N. Okeke and M.W. and Yakoha. Our contacts, in case of further clarification, you can contact us on these numbers we have. First, Napoleon Kure, 080-3636-2105. Hassan Buki, 080-65-50-4346. Stay home, stay safe, and keep learning. See you in our next class. Thank you.